In this demo, I am going to talk about Apache Iceberg format versions V1, V2, V3, and going deeper into what is V1, V2, and V3 releases, the corresponding features, the improvements done over each release, also the migration paths. Let's say if you are on V1 and want to migrate to V2, or if you are on V2 and you want to migrate to V3, and what drives the migration from V1 to V2 and V2 to V3. So let's talk more in this demo. So agenda of this particular session is going over the iceberg architecture and the overview of iceberg architecture, and what is format 1 or release V1, and format V2 the release V2, the format V3 the release V3 version of iceberg. And you can also take a look at I've given high level details of V1 is for the foundational one, and V2 is more of a enhancement on the row level operations. V3 is more of an efficiency and expressiveness, right? And version comparison matrix between V1, V2, V3, what it supports, what it doesn't, right? And what is the migration plan from V1 to V2, and migration plan from V2 to V3, and then finally when to upgrade and how you decide when you want to upgrade from release 1 to release 2 or release 2 to release 3. It is important. Iceberg is an open table format, it is evolving, and everybody is now exploring options related to open table formats and open lakehouse, leveraging Iceberg as an open table format, and then leveraging some of the REST catalogs that supports Iceberg. Let us go deeper into this particular agenda. Iceberg architecture, there are three layers in it. One is the catalog layer, and then the metadata layer, and then the data layer. How each layer is different, right? Catalog layer, that is where you save all your current metadata pointed to a table. For example, if you are using Polaris as a catalog or Hive Metastore or any REST catalog for that matter, let's say when you create an iceberg table, like create table name, and all your columns using iceberg, right? It is going to create an iceberg table in the metadata, but when it does, the metadata the supports to point to the latest metadata pointer. The iceberg table definition always points to the latest metadata pointer. That is where the catalog layer comes into picture. So you do not have to give a specific position every time. So if you want to retrieve the latest data, always just select star from that particular table. It will always drive you to point to the latest metadata pointer. So it is always up to date. The metadata layer, I think we talked about in my previous videos. There are files that drives what how the metadata is defined in Iceberg. One is metadata.json file that will have the basics of the initial pointer, and then it'll also point to a manifest list file that will have list of manifest files, and it'll point to all the manifest files. And then we can talk about what each one contains in the next slide. But so if you take a look at all of this metadata is wrapped under the schemas, snapshots, partition specs, sort orders, min max keys, right? And the pointers to each file, right? End of the day, how you want it is just to point to a particular data file when you read a particular snapshot. So that is all about metadata layer. Let's talk about data layer. What is data layer? The actual data. It could be on Parquet, ORC, or Avro files. I've seen majority of the companies use Parquet as the file format, which is more efficient when it comes to data lakehouse. But Iceberg also supports ORC and Avro files. So, and in addition to this, it will also have the delete files. It could be positional delete or equality delete or deletion vectors. We'll talk more about each one of them because in release 1 you'll see more of an equality deletes, and release 2 will support both positional delete and equality deletes, and in v3, which is the format 3 release 3, you will see primarily the deletion vectors, which are very efficient in deletion of the files, deletion management. Every iceberg operation, the flow is it starts with catalog that goes to the metadata and point to a data file. So it is important to use a catalog when you are actually retrieving the data from an iceberg table format files. So let us talk more about the format v1 and the foundation of it. The format v1, the key features that were released in 2018 from iceberg community is snapshot isolation, which means every write procedure an atomic snapshot produce an atomic snapshot. So readers see a consistent view. When you have a snapshot that is written, readers means any compute engineers wants to read the data. It, like, let's say if I have Spark reading the same data and Trino reading the same data, it will ensure that it guarantees ACID transactions, which is which supports the relational database management system, right? So we all know what ACID means when you are in data warehousing or database um, data lakehouse concepts. So there is a snapshot isolation for every snapshot that actually does the commit a transaction. Schema evaluation. We all know schema changes rapidly nowadays with the new requirements. Let's say if you create a table from ABC and have some column C1, C2, C3, but in the future, if I want to add column C4, you can add. It supports, Iceberg supports. Let's say if I want to drop C3 because we are not going to get any data in that, you can drop it, right? It supports. I want to rename some C4 to C4 underscore 1. You can do that. And you can also reorder the columns with C4 to start with and then C1, C2, C3. You can also do that. When you do that, Iceberg doesn't have to rewrite the whole data. It just saves that schema and supports the schema evaluation. It is important in lakehouse architecture. Hidden partitioning. So what is partitioning? When you create a table, you create a partition by a particular column. Typically, you do that to partition the data. When you read the data using partition by column, it gives a better performance because it will directly points to that particular partition and retrieves the data. What Iceberg supports is you do not have to specify a column when you are querying, because when you create a table, you can just define on which column you want to partition by. It supports functions like transforms, for example, identify, bucket, truncate, year, month, day, hour. For example, if there is a timestamp column, I want to partition it by year, right? So when I'm creating a table, I would say partition by year of particular column like timestamp. So under the hood, it just creates that partition, but it doesn't have to rewrite that. So the metadata carries that information. When I select a particular years data, when I'm writing it, it doesn't have to look for a particular partition key. It goes directly to that year when I give that in the where condition, because under the hood it does support the hidden partition. It is an important feature in Iceberg. Partition evaluation. Let's say today I have partitioned by uh, year, but I know the data skew is more when I'm partitioning by year. So I thought about partitioning it by month. So when I'll do a create a replace of the table and add partition by month. So from that time onwards, the partition changes and it partitions by month. So the snapshots are written by partitioning of a particular month. So when you go back to the older data, you still see the partition by year, but it also carries from current transaction onwards. Uh, it supports the partition by month. So the partition is changing. So which means that it is evolving. So Iceberg supports the partition evolution. Time travel. So let's say query any past snapshots by ID or timestamp. Let's say if I want to uh, see the data before the update on a particular date, like 10 days back, right? So I can just go back and say, hey, what is select star from this particular date is of a particular version or a timestamp of a particular day, right? What it does, it goes to that particular day and look for the snapshot and retrieves the data. There may be a couple of updates done on that particular snapshot later, but you want to see what was there around that time, and then you can clearly see with time travel feature. The manifest based tracking. So manifest files will always point to the data files, but the manifest file tracks every data file with column level stats. It'll include min and max and what columns to prune and what partitions to prune and all of that. So that would help before it even goes to the data. When you query it, your manifest is going to prune based on the condition that you provide in the query. So that's a very powerful feature. Multiple file formats. By default, if you don't specify anything, it supports Parquet, and but it will also support ORC and Avro as a table format for the data files that are residing in Iceberg. Append only. Uh, Part of V1, it was append only, which means it is copy and write. It supports copy and write. What it means, let's say if I'm inserting the data, it creates a new snapshot. Let's say if I'm updating the data, what it has to do, it has to create a uh, new data file. Update means what? Like, so it is going to mark the old file as a delete and insert a new record with an updated data. So it is always append only, but it has to rewrite the files. That means the files gets accumulated and rewritten. Obviously, there is a write performance hit in this case. So there is no merge and read in version 1. We'll talk about what is merge and read, and there is no row level delete files. So it's all append only in V1. So it has to rewrite. The write is comparatively slower, and because you rewrite the files, the reads are more faster. So those are the key features of format V1. Format V1 and metadata structure. Let's talk about we talked about different metadata files, right? Metadata.json, manifest list .avro file, and manifest file .avro again, and then um, they all point to data files. The data files can be on Parquet, ORC, or Avro. Let's see what is that metadata structure that resides in metadata.json file. That is the first file that will be accessed as the default when you create a table or query a particular iceberg table. It will have a format version. Uh, it could be 1, 2, 3 based on the current formats. For V1, it is always 1. It will also carry a table UUID, and then it will also carry a location of that particular data, and then it carries the schema, that means all the field IDs, and then it also carries the partition spec if there are any partition by columns, and it'll always point to the current snapshot ID, and then also it lists the different snapshots that are available and snapshot log also. So these are some there are snapshots and snapshot logs are based on the arrays, right, or the list. So these are different fields you would see in metadata.json based on the V1 architecture. And then manifest list. So metadata points to manifest list. The manifest list will have manifest file path. That means it will point to a manifest file. And then what are the partition summaries? For example, for a particular partition, what is the min and max value or the aggregates and all of that. And then added file counts for each file. It will have the list of counts and deleted file counts. So for each files that are deleted and how many files are deleted, how many files are added. So it's gonna just give the details of the manifest uh, file. And For a particular manifest file that points to a data file, it's going to give the details of the list of manifest files and each manifest file and corresponding manifest file path, and then the partition summary and the list of files that are added part of that manifest and list of files that are deleted. So if you observe carefully, it is all metadata driven. The manifest file will have a status 0 for data, and then it will have the file path of that particular data, and will also have the record count of the data file, and then it will list the column lower and upper bounds. Like for example, if employee id is there from 1 to 100, then it lists like 1 as an employee id and 100 is the upper bound. So when you are actually querying the data of min and max or counts, right, you really don't have to go to the data files and pull the data those metrics. It is important to understand the metadata structure of format v1 or the release v1. Let us talk about format v2 and what are the new features that are introduced and how it is going to how it is going to operate row level operations. The format v2 and its key features. The v2 is released in 2021, 3 years after the v1, and the v2 supports merge on reads. We'll talk more about that. It will also support positional deletes. It does support equality deletes, and then it will support merge into, that's an upset. It will also have sequence numbers added. It does support named branches and tags. It will define the rest catalog specs. It will also have row lineage, that means row id, so that you can easily identify a particular row of a data file. Let us talk about merge and read. We talked about copy and write in format v1, which means it does the rewrite of the files if there are any changes like updates or deletes. So that needs, as we mentioned, there is a bottleneck in write performance, but reads are very faster. But merge and read is a lazy reconciliation at read time, which means during the write, it does write all the files and it doesn't have to rewrite. That means writes are faster. But when you're reading, it has to reconcile, which means, hey, what files I have to omit and what files I have to add. So what it does, it avoids full file rewrites on updates and deletes. It is essential for CDC pipelines, most importantly, right? So because you don't want write performance to hit when there are like frequent changes coming on reads, writes, and updates, right, or deletes. So, but you take care of that using merge and read. While reading, just take what you wanted, meaning delete. You just go and verify if it is a delete file or update file, and omit what is not needed and take only what is needed. So obviously there is difference in reads between v1 and v2, but there is a reason why v2 is more popular because of the cdc changes, and then you can like metadata change that can also just improve the read performance. It's not just because the rewrites are not done, it may not increase the read performance, but relatively because it is metadata driven, you can still see a better performance on read. The positional delete files are introduced. What it means, for a particular file, it will add content equals to 1, which means it marks that the file with delete when it updates the content equals to 1. It marks the rows invisible by the file path and the position, which means in the metadata, it will also have, when you apply for positional deletes, it have the file path and which position that you want to delete. For example, let's say I want to delete employee id equals to 5. What it does, it will carry that particular when you do the delete operation, it is going to have that a particular data file where the employee id 5 is there, and also just marks its position, right? So it doesn't rewrite, but it says this is a position that I have to delete. It will identify which is the employee id 5, and then it doesn't rewrite. So you have the data saved in the metadata. It enables efficient row level delete with merge and read. So when you're reading, and it will go look for the file path and positions, and then it ignores them, so it will only retrieve what is not, it excludes the records with that particular file path and the position. What is equality deletes? It will also mark content equals to 2 for if it supports equality deletes. So when it comes to equality deletes, marks row invisible by column value, which means like, let's say it's gonna say employee ID equals to 5 as the column, right? So that is going to be there in the metadata. Typically it is used in CDC, and then it is deprecated in V3. We will talk more about when we are going to talk about V3, and it is replaced by deletion vectors. Let us see how equality delete does is, it's gonna go check, okay, if there is a delete file, and then it goes to that column, and then every time it scans the data files, it checks whether there is a column of employee ID, and check if there is a value of 5, then it will eliminate those records. That is how equality delete works. And then you have merge into is supported. A full conditional insert, update, delete in one statement is supported, so which is typical in lakehouse implementation. We have merge into, and it is powered by merge and read, delete plus insert files. And sequence numbers, the last sequence number is required in metadata. It ensures ordering across concurrent writes. So when it is writing the data, so it will make sure that it will add a sequence number and will keep the latest sequence number. So it is important, the new feature added in v2 for concurrent writes from multiple engines, or same engine from different parallel processing steps. It does support named branches and tags. Mutable branch refs for ETL isolation. What it means, like, you can create a branch called main or develop or something, and then you can create a table referring to that particular branch. So your table from that particular branch is a mutable branch. And you can also apply immutable tags. For example, you can say employee ID is, for example, employee um, email is sensitive information, like you don't want to share, like classify that with a tag like sensitive, right? So typically you can also use immutable tags for audit checkpoints and fast forward merge and all of those things. So it will support named branches and tags. REST catalog spec. So Iceberg v2 supports REST catalog specifications. So it is a vendor neutral HTTP catalog API. It enables Polaris, Nessie, or Glue, and other REST catalog backends. So you can have a REST catalog and then use. It is easy to read Iceberg tables with REST catalog. So it will support the REST catalog specifications. So what this helps is, you can just have a catalog that supports REST API, and it will make you vendor neutral, so you don't have to depend on a particular vendor like AWS, Snowflake, or Databricks in that regard. And you'll just use the REST catalog specification, and if you use any catalog that supports REST API, and you have an option to do a read write operation, the REST catalog. Row lineage. Internal row ID tracking added for every record that is there. So this is the foundation for positional deletes, because positional deletes needs a row ID, right, at the position. And so to refer a particular position, it uses the row ID. So it is foundational for positional deletes to reference specific row position. So these are key features of v2. So format v2, positional versus equality deletes. We talked about how they can be differentiated is by defining content type equals to 1, which means it is positional delete. If content type is defined as 2, it will go through equality deletes. The file format of positional delete will have a Parquet file with the file path and position of the columns, right? So you, that is, we talked about row ID, right, position. And typically a Parquet file will have 8 to 15 KB per batch, even for one row. so minimum. And it identifies by exact file path and the row position. And it uses a hash join data and applies the delete on top of the data that is retrieved. And so a scope is for a particular data file, and then within the data file is a specific file. Every file you see a file path and the columns, and it is written by Spark Flink after scanning um, file. So typically when we say Spark and Flink here, it is like any compute engine. When you write, it will create the positional delete with content one. It will have the file part on the row position when you want it to use for positional delete. So use cases are typically when you have a lot of deletes and updates and merge via DMLs, right? So, but positional delete is deprecated in V3, and it does use deletion vectors that gives a better performance than positional. Let us talk about equality deletes. So file format Parquet, but equality deletes will have column names and the values, right? Size is tiny, just the key value stored in this case. Identified by column value, for example, order ID equals to 10 in this case, but typically, as I mentioned earlier, if it is an employee ID equals to 5, something like that. The read is a full table scan join, which is expensive because it has to retrieve the data file and look for that particular every file that it retrieves, check if that column is there, and if it is there, then it goes and excludes that particular value. So it is very expensive in general. The scope is table wide, all data files are scanned, which is very expensive when it comes to read. It is written typically by CDC engines. When you want to use Flink or Debezium and write the data into Iceberg, it typically creates equality deletes. So it will have all of those columns with those updates. All of them will be added with the columns and the values of those changes. The use cases are mostly the CDC delete events, key known only. For example, if I know like employee ID equals to 5, I know the column. But let's say if I delete from table, um, if I'm not putting any column, but there are certain cases where you put, let's say, partition or something, right? The columns are not there, so that you typically have to deal differently. The general use case for equality delete is when you define key columns to delete. And this is also deprecated and phased out. The V3, it doesn't support equality deletes because of the expensive nature of the deletion. Let us talk more about format V3 efficiency and expressiveness. Format V3 key features 2024 it is released, and it is one of the most popular features because of all the issues that you see in V1 and V2. The V3 is primarily for efficiency. Efficiency means like performance improvements, but it also adds little more additional data types called variant and nanosecond timestamps. And metadata of this particular V3 has changed a little bit. Let us talk about that. V3 supports deletion vectors. Deletion vectors are the replacement for positional deletes, and typically it will create a puffin file that will have bitmap blob that looks for a particular position that it's gonna delete. So you don't have a file path and position, it will directly point to that particular position where it has to delete in a file, right? Typically these roaring bitmap blob files, which are also saved as .puffin, I believe, that will have 50 to 300 bytes versus 10 kb files that you see in the positional delete. So there is an additional data bytes are being added because of how it uh, creates a new file. So variant type is semi-structured JSON like data. You know, many of the data lake houses will have data types such as JSON and then XML and all of that. Currently, as of V2, they don't support, so you define it as a string varchar, right? But now you have variant type. So typically, you see the hierarchical data saved in Snowflake is defined by a variant. Now Iceberg supports variant, right? Because it is very, it gives better performance when you define as a variant for semi-structured data. So it can easily scan the hierarchies. There is additional data type improvements in terms of timestamps. It will support the nanosecond timestamps, and also it will support default column values. You can now initially set a value to a particular column. There are puffin. I don't know if it is puffin or puffin, but maybe let's call this puffin statistics files. um, NDV, hyperlog, and theta sketches, min max stats. So the statistics file has hash map values of those min and max stats and theta sketches that enables better query planning and file skipping. So it knows what files to be skipped and what files to be scanned. In other words, it knows how to prune the files that are not needed. It does support geometry and geography data types. It is primarily used for first class geospatial types. And a lot of companies now uses the geo geometry and geography data types at the data. So V3 supports these two data types. Catalog tracked views. So there is logical view definition stored in the catalog, and create view, replace view, and currently you can create a view in Polaris that supports REST catalog. So they can be tracked easily via V3. Multi-level namespaces. You have nested catalog namespaces. For example, ABC is the namespace. Under that, BCD and then DEF, like that you have nested. So it will enable finer grained access. Like it can define the access at a finer grain at the lowest level or at the middle level or at the root level. And it will also help you to um, provide the row level security at catalog layer. That's very important because you need row level security on if I want to query some data and I want for a particular user, I do not want to show some data that is not needed. So it can define, it will support that fine grained access. Let us see format v3 deletion vector versus positional delete, because positional deletes are deprecated in v3 and deletion vectors are supported. In v2, for positional delete file, you have a separate Parquet file for each delete operation. But in deletion vector, you have an additional file of a puffin file that will have roaring bitmap blob. So the v2 contains the file path and the position of a particular deletion column. In this case, it will contain the bitmaps only 1 bit per row per position. So it will have a bitmap hashed value. So the size of this particular separate Parquet file for deletion will have 8 to 15 KB. There is a Parquet overhead, but in this case there is no Parquet, so it will just a dot puffin file with 50 to 300 bytes of the file. If there are n deletes, then it will create n extra Parquet files. For example, 100 deletes means 100 extra Parquet files in positional delete. Whereas in V3, if it is n deletes, the bits set in same bitmap. So it will create that like 100 deletes. Instead of creating 100 deletes in the same bitmap file, puffin file, it will have all of those deleted information. Phase 5 read, open all delete files first. The way phase 5 read means it's a step where it reads all the files. So what it does, it'll read all the delete Parquet files first, and then it goes to that like it look for the position and the file path. If it encounters that file and now you have the position, it will exclude that data. So in this case, because it has to read all the delete files, it is expensive because you still have to read all of those delete files, although The size is smaller, but it is still um, an expensive when it comes to time. Whereas uh, in V3 deletion vector, it gets range get blob bytes that goes in parallel. So it gets all of those blobs that has the deletions are specified, and it doesn't have to read all the parquet files which are deleted. It has that puffin file that will have all the hash map values, and that will be saved. So it does in positional delete, it has to do a hash join file versus delete file, and then retrieve the data that is needed. Whereas in the deletion vector, it checks the bit of that particular position, and it is always order of one. And then it will also maintains that in the cache while it is doing. So when you're doing accumulation, so because of a lot of files that are created, there has to be a compact. Uh, we have to run compacts like because of all of these delete files, then you have to make them to bigger files. So compaction is important because of accumulation of multiple delete files in V2. In this case, in V3 deletion vector, a flat cost regardless of delete count. So it is just one particular file that will have all of this map data. Um, so the cost remains same across, although there are a lot of delete counts. So in positional delete, if there are 100 deletes, it has to open 100 files per query, right? Every time. But in this case, in V3, which has deletion vectors, 100 deletes, but still one bitmap per data file. So one data file will have one bitmapped file, dot puffin file, and then it will just 100 deletes on the same file. It just uses this one. Whereas in position delete, it has to open for every delete, it will create a delete parquet file, and it has to scan all of this. But in this case, for data, it's only one puffin file. So with that, we covered the deletion vector versus positional delete and how powerful the deletion vector feature in V3. Let us see a version comparison matrix. So I have the feature name here and the V1, V2, V3. How it started with V1, what is included in V2, and what exactly improved in V3. So when it comes to format version, V1, V2, V3, but snapshot isolation ACID, all versions supports. Schema evaluation, hidden partitioning, and then partition evaluation, time travel, and copy on write, update and delete. All these versions will support copy on write. Let's say if you are on V3, but if you still want to support copy on write, you can define that in the table properties. Right, so it does support the copy on write, because it has to rewrite all the files and you want the reads to be faster. So there are some cases where you still use copy on write if you think that you don't want that delete or the read operations to be even a little slower. But what is improved from V2 to V3, from V2 primarily, is you have merge and read is introduced, positional delete files are introduced, equality delete files are introduced, and then named branch and tags are introduced, and REST catalog specifications are introduced. That is part of V2 and V3 as well. But the positional deletes and equality deletes are deprecated in V3, right? Because you have deletion vectors that gives very good performance. So it is important. It is better to identify if there are a lot of DML operations with the delete. It is important to look for V3 at this moment. And then additional features that are part of V3 are deletion vectors, variant types are introduced, nanosecond default column values are introduced, nanosecond timestamp data type is introduced, puffin files, puffin statistics files, which means it will have all the statistics of those deletions primarily are introduced, geometry and geography types are introduced, and catalog track views where you create a view in a particular catalog and the iceberg can track that particular metadata. So all of these new features have introduced in V3. So in this particular slide, we are explaining primarily on the comparison matrix and what is introduced in V3 and what do we have in V2 and how it started in V1. How do you migrate from V1 to V2? Migrating from V1 to V2 step by step, I have 8 steps listed here. The first is, first check your engine compatibility. Are you using Spark or Flink or Trino or any Iceberg supported engines, right? And then the V1 only supports if your Spark is greater than 3.2 or Flink is greater than 1.14 or Flink Trino is greater than 380. So, so understand whether when you are migrating from V1 to V2, whether your engine is upgraded first with the supported versions. Then audit the existing tables. Check what is the formatted version of a particular using the table properties query. Select all of those the tables, right? And then alter the table with format version equals to V2 by setting the table properties, right? And then set the right modes for merge and read. Let's say if you still uh, you it won't change by default if you set it to uh, default from merge and read to copy and write to merge and read. You definitely have to set write delete mode, write update mode, and write merge mode to merge and read to support these new operations on the merge and read. And then enable sequence numbers. How do you enable it? The V2 requires last sequence number in metadata. It is auto set by compatible writers. Update catalog integration. For example, let's say if you are using some catalogs that doesn't support, right? Um, so let's say switch to REST catalog like Polaris or Nessie if still on Hive Metastore for full V2 support. I know there are caveats with Hive Metastore. They support V1, but if you are moving or planning to move to V2, it is important you look for those catalogs that does support V2 version. Right now, the most popular ones are Polaris and Nessie. Run initial compaction. So what it means, right? So call the rewrite data files table to clean up any pre V2 file layout issues. So it when you do that, when you're rewriting, what um, it does initial compaction and it does change or rewrite the data files to support to V2 and then it leaves the older files like that. Then it is important to clean up all of those the files that are orphan, right? So rewrite data files is important to migrate it to V2 version because the older files will still be pointing to V1 and you want to be retrieved via V2 and use the V2 features. And then finally verify with metadata tables. Get the table snapshots, confirm operation types, show override for DML. So when you do a select star from table.snapshots, it's gonna tell what are the snapshots that are available. And if there are any snapshots that are not needed, you can expire them by calling an expire snapshot stored procedure. So that is how you migrate from V1 to V3. On a high level, first check the engine compatibility, then look for the tables that are pointing to V1 and then upgrade it by running an alter command and then set the write modes to merge and read and then enable the sequence numbers to support V2 features and then update the catalog integration. It is important to use REST catalogs to support the full V2 support, V2 versions, and then do an initial compaction, rewrite the data files to support uh, any cleanup of any of those older files and rewrite all of those files to support V2 and verify with metadata tables to look for the snapshots that are available. And if they're older than a particular date, just expire them. So that's in a nutshell from V1 to V2 migration. So here I have some Spark commands. What we talked about in that particular slide, the Spark SQL initially getting the key and value from catalog, DB orders and properties and where format version. So it's going to display the format and in The next step, you have an alter table, set table properties, and in third step you are actually adding additional alters to the table with the table properties and merge and read, and then call a stored procedures to rewrite the data files to support the v2. So these are primarily some of the operations that you do part of your um, v1 to v2 migration. Your updates are primarily metadata only, but you need to rewrite to just delete some older files that are not supporting v1. Also think about your readers are supporting v2. For example, what engines you are actually using, what catalog you are using. For example, if you are using Spark, using Polaris, right? Is the Spark version is supporting v2? Is your Polaris version is supporting v2? It is important before you upgrade. It is you have some checklist, right? What is the catalog you are using, what is the engine of reading, what is the engine for writing, right? And are they all supporting? So make sure that you have all of the checklist tracked. Let us see from v2 to v3 migration. When it comes to v2 to v3, it's a similar steps. Let us say first we'll check for if the table files have any positional deletes. So how you can identify is by looking for content. So content 1 means it will have positional delete files. Content 0 is just direct insert, and content 2 is equality deletes. So, and then check for the engine compatibility. We talked about it already. Look for all of those engines readers, and then are they supporting v3, right? And before you upgrade, and compact to remove positional delete. So once you know that, you have to rewrite the data files first, so that it does uh, do a compaction to remove all the positional deletes, um, and then expire old snapshots. Now once you do compaction, you have all of those older files that will remain orphan, so you'll have to remove all the older snapshots. um, Basically expire the older snapshots and then remove to physically delete all of those files to clear up some storage. And then once you do that, upgrade to v3, set your table properties to v3 and enable deletion vectors. So you have a write detection vector enabled equals true is data, the property for the table that you have to enable. And then use the write delete mode equals to merge and read. It Iceberg v3 does still support merge and read. And then verify if the dv writes by running a delete, then check whether select content from orders file where content 2 is appearing or not. So in that way, so it should appear with content 2, but you will have to see whether the delete running a select content from the orders files and check whether what is it actually referring to. So when it comes to this Spark commands, you have step 1 is to rewrite the data files with uh, using delete file threshold as 1, and then you still have to put it strategy equals to bin pack. This is all the information that you can get it from Apache Iceberg documentation. Once you rewrite those files, you have older snapshots, so you have to expire them and remove all the orphan files. You don't need them, so by calling a remove orphan files, so in that way your storage is cleaned up, and also you are expiring the snapshots that are not needed. That means your pointers will be lost, right? And then grade to v3 to enable the deletion vectors. Now once you rewrite this with all of this uh, the table strategies that we talked about, then set that format version equals to 3, and then set the delete mode and update mode to merge and read, and enable the deletion vector. So that way when you query the same table, it uses a deletion vector. Finally, verify the dv writes by running a delete command on the orders table. In this case, as an example, the status equals to cancel. Then how the way you check whether the deletion vectors is working is by looking at the from the orders the files, check if the content column value and the count, right? So if the content is showing 2, that means it is supporting um, v3 version. So it is important. The first step is to compact before upgrading, and then rewrite those files with the delete file threshold equals to 1. Then once you upgrade to v3, it is downgrade is not supported. It is always important to understand backward compatibility or the downgrade of v3 to backward compatibility supported, but v downgrade is not supported. So all readers must be v3 compatible. You're using Spark, Trino, or any compute engine, so they should also support your uh, the compatibility. So understand whether those versions of those readers are supporting v3. So if I have to plan for v2 to v3 migration for my project, I have a checklist, put it in Excel, and then look for, okay, verify if the position, if the current uh, the files having positional deletes, right? So then if there is a position delete for a particular file, you replace that with deletion vectors. Then so how do you identify that is check for if the files has content equals to 1, right? Then make sure that after this whole migration there is no files with content equals to 1. Look for the table property, and then it should always point to 3 and v3. And then check for right deletion vector enabled. It must be true for all of those tables. Check for delete mode, always merge and read in v3. And then test, check if there is any content equals to 2, that means it supports dv, and it appears after a delete. When you do a delete, you have a content 2 will be updated in the file. And test the file size. There will be a deletion vector file that is created that will have less than 500 bytes. It's a tiny blob. And then look for a cleanup. Old snapshots expired, no positional delete references. So you don't want to have an older snapshot that is residing there, because you expire them, so you don't refer to that older snapshots from your metadata files. So and then finally, once you expire them, and because the data files are rewritten, you don't need to find them, so you can just delete all of those positional delete parquet files, right? So in this case, primarily you are deleting the position delete parquet files only, and you are rewriting your metadata with content uh, 2, that is going to be a deletion vector. So you have some select queries on the right side with select content of the order files, and then every checklist that we have, every point that we have a particular validation step that is written in SQL. So with that, we have covered v2 to v3 migration. So what are the key decisions that you look for when you want to upgrade? And this is a decision guide, right? v1, v2, v3 are the releases from Iceberg. The scenario is, let's say, append only batch ETL. There are very rare deletes. v1 is ideal because your deletes are very less, right? And then when your deletes are very less, you want a higher read performance. Every time you write on the batch, it rewrites the the data files, which is copy on write. If you are on v2, it is okay. If it's not bad, but if you move to v3, it's an overkill because it has to like no deletes, but it has to write those dot puffin files. So let's say if you have an ad hoc delete update with low frequency, sometimes you want to delete the data or update the data because you have delete commands written. Um, Ideally, it is v2 where it look for the positional deletes, and there is still less overhead on v3. but V1 is very slow because it has to rewrite the entire files and the copy and write. Let's say if you are using CDC, or if you are using high frequency merge into pipelines. CDC, which is streaming, like let's say if I am reading data from SQL Server and writing into an Iceberg table, if I am reading from Oracle changes and writing into an Iceberg table, replicating the data, there are heavy frequent updates, too many updates, right? In those cases, V1 is not an ideal choice. V2 it is okay because it does support the positional deletes, but the best is V3 because it will create a hash map, bitmap file, puffin file that helps using deletion vectors. Now, semi-structured JSON columns, if you want, V3 is an ideal format because it supports variant. V2 and V1 does support, but you have to define that in a string format. If you have an option for nanosecond timestamp precision needed for your business use case, V3 is the better option because it does support nanosecond timestamp now. If you have geospatial analytics, geotypes are supported in V3, not in V1 and V2. You define them as strings only in V1 and V2. There is a time travel and audit tags needed. The tags are started building from V2 and also supported in V3. In V1, it does only snapshots and no tags and audit tags. Time travel is there, but it does use snapshots. Multiple concurrent writers like high write QPS. If I have different engines like Spark and Trino writing the data into Iceberg, right? Multiple writes happening at the same time. Um, V1 is okay, it does support. It still follows the tacit transaction, but V2 and V3 are the better choice. So in a nutshell, I'll go to V3 if I have CDC with frequent row deletes or high frequency merge statements, right? I'll go with V3 and also look for if my data is being written in JSON or semi-structured data with supports nanosecond and also require geospatial data types. I would go with V3. But if it is like a regular batch processing, like it doesn't need a lot of deletes, will still stay with V1. But V2 is better if you want to just improve a little bit on the positional deletes, like ad hoc deletes and updates with very low frequency. With that, we have covered what is V1, V2, V3 in Iceberg and what are the key features of all three releases and how to migrate from V1 to V2 and V2 to V3. And as I mentioned, it is difficult. There is no way to go back once you upgrade to a higher version. It is important to understand your readers and writers, which engine you are going to read and which engine you are going to write, and look for its compatibility. And then finally have a checklist before you upgrade to ensure that what is your actual decision making process to upgrade to a different version and what are the checklists that is needed to do the operation. So with that, we've covered um, the Apache Iceberg Foundation releases and their upgrade strategy. Thank you all.